Hi guys, this is lesson 4.07 for chemistry, and the title is Electron Configuration for N equals 1 and N equals 2 energy levels. So we're talking about the electrons that are found in the first and second main energy level. We're going to be introducing some new terms. I'm going to use my highlighter here. So if you look at the table that I've got here, I have the element, I have total electrons, I have something called the orbital diagram, and then I have electron configuration. And the writing's a little hard to read, so we'll be rewriting all of this. First of all, if you're looking at an element, so in this case, lithium, how do I know lithium has 3 electrons? Well, the atomic number for lithium is 3, which means it has 3 protons. And we're assuming that all of our elements in this chapter have the same amount of protons and electrons. So here beryllium has 4, we've got 4, boron has 5. So it starts off, the first thing that I have is an orbital diagram, and I'm going to write definitions over here to the side. So orbital diagram is a dash diagram to represent atomic orbitals. Now, in this case, they used boxes, but every other time we do an orbital diagram, we're going to use dashes. And so I'll show you, we'll do an example of one before we're done. On this other side, you have electron configuration. So electron configuration I better write the whole thing out. So electron configuration is shorthand for the location of electrons, or specifically an electron's location. So if we're talking about the last electron, the third electron in lithium, this would be the orbital diagram notation for lithium, and then the electron configuration for lithium. We're going to do, so let me show you what when I say dashes, we're going to add another one down here. We're going to do oxygen. And we're going to do dashes instead of boxes. And I don't want to write more than this, but again, we will always use dashes. So lithium has 3 electrons. So when I start to fill up orbitals, and if you can see here at the top, what color is going to show the best? I'm going to use kind of a highlighter color. So this says 1s, this says 2s, this says 2p, and one of these would be px, one would be py, one will be pz, but we don't have to differentiate that. And then we're not going to, I don't know if we really use those, but that's a 3s. So when I fill, when I start to try to figure out where my electrons are, you'll notice I have 2 dashes in the 1s, and then I put 1 dash in the 2s. What I could do is I could put dash, 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 but that's not what happens. And there's a reason for that. We have something called the Aufbau principle. The Aufbau principle. And the Aufbau principle says that lower energy levels fill completely before higher energy levels start to fill. Lower energy levels fill completely before higher energy levels fill. So because of that, the 1s has to fill up all the way, and then my third electron goes into the 2s. This is the orbital diagram notation. the way that we write that in electron configuration is we say 1s2, 2s1. That means that my 1s orbital has 2 electrons in it. My 2s orbital has 1 electron in it. So these are the same way of saying the same thing. So the exponent in electron configuration, the exponent tells us how many electrons in the sublevel. All right, beryllium has 4 electrons. The 1s is the lowest energy, and so we have to fill the 1s first. Then the 2s is the next. So electrons 3 and 4 go in the 2s. That means my electron configuration is going to be 1s2, 2s2. That means the s orbital in the first main energy level is full, and the second main energy level has an s orbital that's full. All right, go ahead and try boron. See if you get it. Pause the video if you need to. So boron has 5 electrons. So we fill the 1s first, 1, 2. And we fill the 2s, 3, 4. And then I put 1 electron in my 2p's. There's 3 boxes to represent 3 orbitals. So my electron configuration is going to be 1s2, 2s2, 2p1. All right, moving on to carbon. Carbon has 6. So here at carbon, we've got 6. So I fill up my 1s, I fill up my 2s, that's 3, 4. But now look at what happens with number 5 and number 6. They don't go into the same orbital. Well, all of these 2p's have equal energy. So these are all equal energy. And the reason they're pairing up separately, imagine this is a bus and you're taking the short bus, the school van to a golf tournament, and there's only 3 people. Are you guys going to cram into one seat? Nope, you're all going to spread out and you're all going to take your own seat. So this even kind of looks like a bus. There's a rule called Hund's rule. I call it the bus rule. HUND'(S), Hund's rule. And in parentheses, I'm going to call it the bus seat rule. And that says that electrons will, let me write that down. Electrons will occupy orbitals singly, and that's orbitals of the same energy level, singly before pairing. All right, so what's going to happen with nitrogen? So nitrogen has 7 electrons. Should probably darken these down. So the 1s is going to fill first. Then the 2s, that's number 3, number 4, and then we're going to go 5, 6, 7. So what's our electron configuration going to be? 1s2, 2s2, 2p3. We didn't do electron configuration for this. 1s1, 2, 2s2, 2p2. Okay, sample problem. Grab your periodic table and take a crack at neon and take a crack at sodium and see how you do. Pause the video here. Okay, welcome back. Let's go through neon. Neon has 10 electrons. So we're going to fill the 1s first, 1, 2, and then the 2s. Then we go singles, 5, 6, 7, 8, 9, 10. So that's the orbital diagram notation, and the electron configuration is 1s2, 2s2, 2p6. Sodium has got 11, so we go the 1s first, followed by the 2s, then we go singles, then we pair up, and we've got 1 in the 3s. So now we're starting to fill that third energy level. So the electron configuration for sodium is 1s2, 2s2, 2p6, 3s1. All right, come back to oxygen. So let's do oxygen as you would do it if you were doing it in homework. So oxygen has 8 electrons. And instead of doing boxes, I'm going to do dashes. So I make this first dash my 1s, and then I do 2s, and then I do 3 dashes for my 2p. And then if I wanted to, I could do 3s. We're not going to go that far. But instead of doing boxes, my orbital diagram notation is going to look like this. I'm going to fill it, and when we fill it, you're going to start seeing me use half arrows like this. And I'll explain why later. So that's number 1, number 2, number 3, number 4, 5, 6, 7, 8. So my electron configuration will be 1s2, 2s2, 2p4. That's oxygen. All right, the last thing we need to talk about on this video is valence electrons versus inner shell. So we're going to do a valence electron. Those are all, I'm going to do capital, all of the electrons in the highest main energy level. If we compare that to inner shell electrons, that's all the electrons that aren't valence. All the electrons between the nucleus and valence. So let's make a column over here. Let's go valence electrons. And let's just do it, we'll look at it 2 ways, I guess. So my valence electrons here, my highest energy level is, it's going to be the number, is number 2. In fact, all of these have a number 2 highest main energy level. This has 1 electron in an n equals 2, so this is going to have 1 valence electron. This guy's going to have 2. This guy's got 3. This guy's got 4, so on and so forth. You know, what happens when I get down here to sodium? What's the highest energy level? 3. So sodium has 1 valence electron. That means it's got 2, 4, 6, 8, 10 inner shell. And this is significant because all of the action in chemistry takes place with the valence electrons. The inner shell really don't do much. So how many valence electrons does neon have? Let's look at neon. The 2s and the 2p both count as the highest main energy level. So neon is going to have 2, 4, 6, 8 valence electrons. Do you remember what category neon's in? It's a noble gas, so it doesn't like to do much. Why? It's got 8 valence electrons, and that means it is not very reactive at all. All right, so our takeaways. We did an awful lot in this one. We talked about orbital diagrams and electron configuration. We talked about how the Aufbau principle and Hund's rule affect how electrons fill up orbitals. We did some practice problems, and finally we talked about the difference between valence electrons and inner shell electrons. All right, that'll do it for this topic. That's all we've got. Thanks for watching and have a good one.